Welcome to Calculus.
Our stress tolerance level has risen so high that nothing phases us.
On this episode, Stevenson will demonstrate
Find the absolute extrema of f of x equals e to the power of negative x on the interval -1 to 1, and it is closed. So step 1, what does this look like? We can do this whole problem without any calculator at all. Let's review our parent functions. I know e to the x looks like this, but the negative is on the x, the input itself, so what happens is it then flips over the y-axis. If the negative was in front of the e, it would look like this. So the purple one is what we want to refer to, but I just want to remind you of that. Based on this sketch now, does extreme value theorem apply? Well, e to the x in general is a continuous function on all real numbers, right? So the fact that I reflected over the y-axis does nothing to change that. So it is continuous, and it's only on this interval that is closed, so EVT applies. Now, why is that important? Now that I know extreme value theorem applies, I now can conclude I am guaranteed both an absolute maximum and an absolute minimum. Okay, next step, find the derivative. Now that we have our derivative, let's find our critical points. When does my derivative equal 0? Well, let's talk about transformations. We just said if the negative is on the inside here with the x, it'll reflect over the y-axis. But then if the negative is on the outside, it reflects over the x-axis. So there's my derivative. Now, will this ever touch the x-axis? In other words, will it ever have an output of an output of 0? The answer is no. Is there ever a time when this derivative will not exist? So we have no critical points to test. What that means, though, is we have to only test then is our endpoints, which means our absolute extrema should come from our endpoints. How do I know that? Because the extreme value theorem applies. And remember, if the extreme value theorem applies, that means I'm guaranteed an absolute max, and an absolute min. So if it's not the critical points, then it has to be at the endpoints. Let's make our table. So remember, when I do my table of values, I'm testing them in the original value. I use the derivative to give me candidates to test, but then when I'm actually checking the actual extrema, I use the original function. Based on this, we can see that when x is -1, we get our absolute maximum of e, and when x is +1, we get an absolute minimum of 1 over e. Let's write our sentence.